Hello students, welcome to another tutorial on vectors. In this tutorial, we're going to look at another interesting question. So this is kind of a tricky question, but really it's not that hard, provided you understand what you have to do. So let's quickly go through it and see what we are supposed to do. So what are they saying? A man pulls a box with a force of 70 newtons along the positive y-axis, while a boy pulls it with a force of 50 newtons, making an angle of 80 degrees counterclockwise with the positive y-axis. In what direction should the second boy apply a force 60 newtons so that the box will move along the positive y-axis? Hint, two values are possible. Now, let's see what we're supposed to do. The first part is to understand what is happening in this question. So let's start looking at how we get the solution. So here I'll quickly go to my table. I just want to get the facts here. So I'm seeing that initially there are two forces which are in play here. So I'll label those forces in terms of M1 for the man 1 and then B1 for the boy. Okay. So what else gets to happen? I want to collect the components. These are vectors, so most likely I have to do with components there. Okay. So what are they saying? Well, they're saying a man pulls a box with a force of 70 newtons along the positive y-axis. So this is along the positive y-axis, meaning it has no horizontal displacement, meaning the contribution or the x component is going to be 0. And all of it is along the y-axis. That is that 70. Of course, this is in newtons, so I'm going to put my newton there, and I'm going to place it there. If you forgot to put the units in an exam or a test, I think you really shouldn't be, you won't be penalized unless otherwise. So then I'm just putting them there. Just putting them there myself. Okay, so that is for the man. How about the boy? Well, a boy pulls it with a force of 50 newtons, making an angle of 80 degrees counterclockwise with the positive y-axis. Well, let's try to picture what is happening there. Well, what I have is, if this is the xy plane, this is the positive y-axis, and this is the x-axis. What this question is saying is that the boy pulls this object with a 50 Newton force, making an angle of 80 degrees counterclockwise. So from the positive one. So from here, going in this direction, counterclockwise means going this direction. Okay, means going this direction until when we make 80 degrees. So this is the force that the boy is pulling this object with. So when you look at the angle that we have, this is where the 80 degrees is. So if you're going to look at your components, the horizontal component is in this direction. And if you compared how the x component is relative to the angle, you see that the x component is opposite to the angle. So we are going to use sine then. And apart from that, the x component is to the left, meaning it is going to be negative. Again, there is that method where you use cos every time in the x-axis. But for that, you'd have to measure the angle from here until when you find your vector here. And if you use this, you can straight away use cos in the x-axis to get the x component, and it will give you the answer. You won't even have to remember to say it's to the left, it has to be negative. The negative will be placed by the fact that you're using the angle correctly. But of course, we'll have shortcuts. So we'll use the angle exactly where it is. But in exchange for that, we'll have to remember that it is to the left, we'll place the negative. So the x component is opposite to our angle. I'm using sine, so it is going to be the vector itself. And for the boy, the vector is 50, so I have 50. Then sine, the angle is 80. But because it is to the left, this vector is going to be, or this component is going to be negative. When it comes to the y component is going upwards, meaning it is positive. It is adjacent to my angle, meaning I'm using cos. So it's going to be the vector itself, 50, cos the angle, 80. But again, it is going up, so it is going to be positive. So I've obtained everything that the question is saying. And now that I've done that, the next thing is The next thing is to get the next part of the question, which is part 1. In what direction should the second boy apply a force of 60 newtons so that the box will not move? So we want to know the direction that a second boy, so I'm going to say this boy to be boy 2, will apply a 60 Newton force. So I'm going to say 60, but we don't know the angle here. So I'm just going to say, okay, let's say this angle is theta. And then here it means that this is going to be 60 sine, what the same theta. But we don't know what this theta is. That's what we want to find, that direction. Now, let's say one thing. In what direction should the second boy apply a 60 Newton force so that, if we finish it, so that the box will move along the positive y-axis? If the box is to move along the positive y, it means that again, it has no horizontal displacement. The x component is 0, and all of it is in the y-axis. So this is now, let me say, yeah, I can use that. All of it is in the y-axis. Let me say ry. So now we want to find this theta here. What you should see here is that if you added all these three, they should equate to 0 in the x-axis. So 0 plus minus 50 sine 80 plus 60 cos theta has to be equal to 0 in the x-axis. So from here, we can make the theta subject of the formula. What we have is cos theta is equal to, this becomes positive, 50 sine 80 over, this becomes 60. And from here, we can get cos inverse of the 50 sine 80. And this comes out as 60. If we evaluate this, we see that the answer that comes out is positive 34.85 degrees. Okay, now remember the hint that we were given. The question gave us a hint. Two values are possible. Why is that? Well, we used cos here, and for cos, there are two possibilities. You see, cos is positive in two quadrants. Cos will be positive in this quadrant. Okay, so we have found our angle as 34.85 degrees. Now we have to remember one thing. Cos is going to be positive in two quadrants. So if we were to sketch this, we see that there are two possibilities because we know to say in the first quadrant, sine, cos, and tan will all be positive. In the second quadrant, only sine will be positive. In the third quadrant, only tan will be positive. And in the fourth quadrant, only cos will be positive. So there are two possibilities here. Either our angle, this 34 degrees, is in the second quadrant, because I'm saying this is positive and I used cos. So I'm saying this has to be either here in the first quadrant where cos is positive, or in the fourth quadrant where cos is positive. If it is in the first quadrant, then most likely this angle is here. This is where the 34.85 degrees is, 0.85. See, if it is in the first quadrant, it means that this vector is fine. Let me use red for my vector. It will mean that this angle is just fine. We state it as 34.85 degrees. But if it is in the fourth quadrant, well, that's a different story, because in the fourth quadrant, it means that my angle was actually measured clockwise from there to there, and this is how it was given as 34.85. But what we want to remember is that angles have to be measured anti-clockwise from the positive x, meaning that in as much as this is the first possible answer, if the angle is in the first quadrant, or if the vector is in the first quadrant. But if the angle, or if the vector is in the fourth quadrant, it means that to specify the direction, now we have to measure the angle starting from the positive x, going all the way until when we reach our vector. In this case, notice that what we have to do to get this angle labeled in green, we have to say whatever that angle is, let me say phi, whatever that angle is, if we added it to this missing, this piece, which we know, that 34.85, if we add them, then we'll get the entire piece, or the entire, a full rotation, 360 degrees. It means that that angle we're looking for, the one that gives us our vector measured anti-clockwise from the positive x, will be 360 degrees minus 34.85 degrees, giving us our angle as 325.15 degrees. So this becomes the second answer. So if the angle, if the vector is in the first quadrant, that is our angle. And if the vector is in the fourth quadrant, this is going to be our angle. Okay, so these are the two possible angles that are solutions to the first part of our question, which is part 1. Now I have to look at the second part. Find the magnitude and direction of the force that a second man should apply so that the box does not move at all. Well, what is happening? Well, what we're saying here is we have, let me just reconstruct our table. So what the question is saying, we have the first man here, then we have the first boy, and then we have the second boy. Now, apart from this, when these two were when they were working on this object, see, I want to use the shortest method possible to work out this problem. So when these three were acting on this object, we got our resultant, and that resultant had zero displacement in the x-axis, but it had something in the y-axis. So of course, for the man, we had 0 there. Here we had a 50, and then this was sine 80. And then at first we didn't know what the angle for the boy was, the second boy. All we knew was this was cos theta. But now we know that this theta can take two possible angles. Either it can take 34.85 or it can take 325.15. Okay, but in the y-axis, this was 70 and this was 50. And lastly, this was not just 50, that was 50 cos 80. And this was 60 sine theta. Okay, now what I first want to do is, you see, this question is kind of, it doesn't say that we are taking it that the second boy is not there. The question is saying if the second man wants to work on this. So our assumption here is that on this system, the man and the first boy are still there, and the second boy is also still acting on the object. Now we want a second man to apply on the object so that the displacement of the entire system is 0. Now, first, let's see the influence of the 3. The influence of the 3 will have 0 in the x-axis. How about in the y-axis? See, in the y-axis, I want to find what this r in y will be just for the first 3, meaning I have 70 plus 50 cos 80 plus the 60 sine theta is equals to 0. So notice that not 0, this is not 0, it's equals to this ry. This is for the first 3, that's the man 1, the boy 2, the boy 1, and the boy 2. This is their influence. It will only have a y component. Then apart from this, what you should realize is that there are two possibilities for the angle. If the angle is in the first quadrant, meaning theta is equals to 34.85, notice that now what we have is ry is equals to 70 plus 50 cos 80 plus 60 sine 34.85. If you simplify this, you get ry as, this is going to be 112.97. This ends up being our ry. But again, what are we dealing with? What are these values? So if we come back here, it's the magnitude and direction of the force. So those are forces. So of course, this is newtons. This is the effect that will be felt on the box when the first three are acting. So if the first three are acting, it's like this box is only feeling an upward push of 112.97 newtons. In the x-axis, the statement said when the first three are acting in the x-axis, we have a 0 there. So all we know is that R in x is equal to 0. Now notice that even if we look at it like this, but this is all we have. Now, if now I was to draw a third step, with only, let me say this is my x comp, and this is my y component. So the resultant of the first three has been summarized into two components, 0 in the x-axis and 112.97 in the y-axis. Now we want to know where the second man should act so that the second resultant, let me say R2, will have a 0 here and a 0 here. The question is saying, if I go back here, find the magnitude and direction of the force that the second man should apply so that the box does not move at all. If the box does not move at all, it means that the forces acting on it have to be equal, not have to be equal. The forces acting on it, they have to be 0 if it's not going to move at all. So because of that, I'm saying that when the second man acts on it, the net force in the x-axis has to be 0, and the net force in the y-axis also has to be 0. So here now I have the second man in x, the second man in y. Notice that here, what I'm saying is the 0 is the contribution of the first three plus mx, the contribution of the second man. This has to be 0. Notice that this just implies that the second man will have a 0, the component in the x-axis for the second man has to be 0 newtons. Now, after that, how about in the y-axis? In the y-axis, I have this. The first one is a contribution of the first three, and then the second is a contribution of the second man. When I add them, they should give me a 0 resultant force in the y-axis. So what you see is, when I add all those forces for the first three, I'll have 112.97 newtons plus the contribution of the second man in the y-axis, but they should add up to 0 because all the forces have to be 0. So notice that this will just give me a y component of the second man as 112.97 newtons. From here, to get the contribution now of the second man, the force altogether, this is negative, it has caused the equal sign. To get the total contribution, it is m in x squared plus m in y squared. Of course, we know where this is going. This is going to be 0. That's just a 0. Plus, this is negative 112.97 squared. Okay, so we get m2 to be, it's going to give us 112.97. This is a square root, so there are two possibilities, either a positive or a negative. If you really want to see what I'm doing, instead of me using this approach, this is 0. Let me say this is going to be negative 112.97 squared. So from here, the square root will cancel with the square so that m2 comes out on the other side as just negative 112.97 newtons. So this comes out as the contribution of the second man. If you look at it, it actually makes sense. The total contribution of the first three, all of it was in the y-axis, and it was in the positive y-axis. It was 112.97. If this object is to remain fixed, the forces to remain 0, it means that when a second man is going to push, it has to be that he opposes the contribution of the first three. So for him to oppose them successfully, it means that his contribution has to be in the opposite direction, which is 112.97. Since the arrow is pointing down, it has taken care of my negative here, meaning that this is negative 112.97, that is positive 112.97. These are forces. Okay, so with that in mind, I hope you guys were able to follow. That brings us to the end of this video. Hope you found it helpful. If you did, let me know in the comment section. And if you haven't, you can make this the video that you subscribe to our channel. Otherwise, we'll see you guys in the next video. This was your tutor.